All right, this is going to be part one for August 17th and August 18th. Depending on what class you're in, this is where we started out. These are the notes. Also, if you missed August 15th and August 16th, we use the same guided notes for that. So if you don't have these, you can go to that post for August 15th and August 16th to download these notes. Also, in part 1 through 4 on that page, if you will, we already went through sine, cosine of these 4 things, and now I'm going to do 2 of these. And you might need your unit circle if you weren't here, or you just want to check your work for that. Anyways, we want to find cosine of 5 pi over 2. We're going to start here. Depending on what class you're in, we did this on Wednesday or Thursday. We might have done this on Monday or Tuesday, but I'm just going to do this for August 17th and 18th. But anyways, if you notice on your unit circle, you can try to find 5 pi over 2, but you won't find it there. And the reason is 5 pi over 2 is bigger than 2 pi. And the reason that how we know that, I'm going to write it over here in the margin, is if we have 2 in our denominator and we're trying to get 2 pi, then 4 pi would have to be in our numerator. 4 divided by 2 gets you 2. Since 5 pi over 2 is bigger than 4 pi over 2, then we know this is bigger than 2 pi. But what we can do is find the coterminal angle here, and then say that cosine of this would be the same as this if the cosine of the coterminal angle, and then solve. So I'm going to do it this way because I know 5 pi over 2 is bigger than 2 pi. I'm going to subtract 2 pi to figure out the coterminal angle. And I'm going to make this a fraction. So we need a common denominator. So 2 times 1 is 2. If whenever I multiply our denominator, we have to multiply, oh, that should be minus. We have to multiply our numerator. So multiply 2 pi times 2. And that's going to give us 5 pi minus 4 pi is 1 pi, or just pi, over 2. And so what this really means is cosine of 5 pi over 2. 5 pi over 2 and pi over 2 are coterminal, which means that cosine of 5 pi over 2 is the same thing as cosine of pi over 2. And if you look on your unit circle, you would find at pi over 2, you would find the coordinate point 0, 1, and cosine is always x, so cosine of pi over 2 is 0. Or 5 pi over 2 is 0, same thing. Alright. I'm just going to do sine of negative 5 pi over 4, and then keep going. So sine of negative 5 pi over 4. If you actually look on your unit circle, positive 5 pi over 4 is on the unit circle. It's in the third quadrant, and the coordinate points are negative square root of 2 over 2, comma, negative square root of 2 over 2. Well, positive 5 pi over 4 is in quadrant 3. Negative, it's symmetrical. So negative would be in the same spot, but above the x-axis. And so negative 5 pi over 4 is the same thing as 3 pi over 4. If you look at the coordinate points for sine of 3 pi over 4, sine is y, so this is going to be square root of 2 over 2. Hopefully you followed that logic. If you didn't, make sure you ask a question either through the website or in person so I can clarify that. But I just want to do that quickly. Now I'm going to move on to redefining tangent. I'm going to kind of do this quickly. If you need to pause and rewind, that's fine. But we talked about SOHCAHTOA in class. And so this means that tangent of an angle theta, this symbol that looks like a 0 with a line through, we call that theta. We just use that as a variable for angles. This is going to be opposite over adjacent. Sine of theta is opposite over hypotenuse. And cosine of theta is adjacent over hypotenuse. So what we did, if you notice here, we have opposite and adjacent. Well, opposite occurs again in sine, and adjacent occurs in cosine. And the reason this is important is if we wanted to use this definition of tangent, then we would need to draw a triangle basically every single time. That's too much work. So what we decided is, I said that I'm going to oppose that tangent of theta, oh no, is sine of that same angle, whatever the angle theta is, over cosine of that angle. Alright, so we're going to try to prove this. I'm going to prove that here. So we said in previous classes that if it's something over something, that's really just division. So we can write this as sine of an angle divided by cosine of that angle. And we see that sine is equal to this. So I'm going to replace sine. It's the same as opposite over hypotenuse. So I'm going to replace sine with opposite over hypotenuse. And we're dividing by cosine is the same as adjacent over hypotenuse. So instead of cosine, I'm going to write adjacent over hypotenuse. Sheesh. Got that heavy hand today. Now we're just dividing fractions. And in order to divide fractions, we keep the first fraction the same. We take the reciprocal, or we flip the second fraction. In this division, we turn that to multiplication. And what we noticed here is that the hypotenuse, we have one in the numerator and denominator. These would divide out. And what we end up with is tangent is opposite over adjacent, which is our definition here. So essentially what we showed here is that we can define tangent in this way. That's true. That tangent of an angle is sine of that angle divided by the cosine of that angle. And we're going to use this division to find tangent of any angle. So I'm going to stop here, and then on the next video, part 2, and the second part, and there's only going to be 2 parts to these notes. We're going to go through these and then stop there. So this will be in part 2.